So, welcome. This is the Introduction to PyGame tutorial, or Introduction to Game Programming, because that's more fun. This tutorial runs from about now till 4:40. So there's a 20-minute break in the middle. If you're not aware, there's tea and coffee and snacks downstairs during the break, I believe. There was this morning anyway. Yeah, the other side, because that's convenient. So yes, it's a 3-hour tutorial with a 20-minute break. And I'll see if I can try and fill the whole 3 hours. So what I'm going to be talking about today is not just PyGame, but some stuff around PyGame, because PyGame by itself is useful, but there's a bunch of stuff you have to think about kind of outside of PyGame as well. A little bit of an introduction about me, so you know where I'm coming from. And then I'll talk a little bit about, you know, what games are and what you have to think about. Then we'll actually go through the steps of constructing an actual game. We'll look at some other game types that you can construct with PyGame, some other applications. I'll talk about packaging your game so that you can just get it out to people who want to play it. Some of the content production tools that I use when I'm developing games. I'll talk about those as we go, but also demonstrate them at the end. And then a little bit of a thought about where you might go from there. I like interactive tutorials, so if you have questions along the way, just put your hand up, go for it, and we'll take it from there. So, I have been programming video games since the mid-1980s, when I started on my first computer, which was a Commodore 64, banging away simple little games in effectively in a command line editor. It was awesome, and it was a great introduction. Couldn't really do very much beyond push characters around the screen, but it was so much fun. I also played a whole lot of games on the Commodore 64, and so yeah, I wrote some, and it was good fun. Then a little bit later, I got an Amiga 500 and then a 1200. And I played lots and lots of games on that as well, and I wrote more games on that because it could do all sorts of awesome, cool stuff. The Amiga architecture. Who's familiar with like the insides of the Amiga? Yeah. It was really neat. For a home computer, it had coprocessors that you could actually program to do their own thing before coprocessors were a thing. Like not just it's a coprocessor that can do floating point arithmetic. These things you could put programs in them, and they could program each other. It was awesome fun. So it was lots of fun to play around with, and it was a really nice system to write little games in. And then I got a job, and I didn't do games for a while, but I did still play them a lot. My first game after becoming a professional software developer was a web-based game, because the web was new back in kind of the mid-90s, and I wrote a little strategy game that my friends could play. And it was atrocious. It was, again, or possibly in the mid to late 90s, so Python web frameworks didn't exist. It was the CGI module or bust, and I used Pickle to store the game state, and so it frequently got corrupted because I'd have two friends playing at the same time. And it was good fun. And then there was a bit of a break. And in 2004, I rediscovered actually writing proper video games through some online game programming challenges, which I'll talk about later. But that kind of rekindled the things. And I've basically been writing video games as a hobby ever since, and contributing to the various toolkits that we use in Python for writing video games. I also created and I run the Python package index, or the cheese shop. I wrote Roundup, the issue tracking tool that the Python project uses and some others use, and a bunch of other stuff. And I also run a website called PyWeek, which is a biannual game programming challenge for Python programmers. So that's kind of where I'm coming from. I do video games as a hobby, play them and write them. I'd really like to work as a video game developer, but they don't pay very well. So, I'm going to be talking about a bunch of stuff today about how you write a video game. You've got now from those USB sticks, there's still one floating around out there somewhere. Yep, thanks. So that's got the whole source to a number of video games, a number of simple games. It also has a step-by-step source for the thing that we'll be developing on as we go. And you can do whatever you want with it. You can poke at it, you can break it, you can take it and extend it and do whatever you will with it. And that's fine. Because when I started out writing video games, I learned a lot from looking at how other people wrote video games, learning by example, and also learning by experimenting and breaking things. So take that and do what you will with it and learn from it, hopefully, because I was exactly where you are today once. So I'd like you all to spend a few minutes to think about what sort of video game you might like to write. Because that will help you focus a little bit on the things that are important to you today, and it may in fact pose or prompt some questions that you need to ask of me today while I'm here, and it's easier to ask me questions while I'm here. So we'll have a little bit of a think about what video games are kind of composed of at a very, very high level. There's kind of three aspects that you should maybe consider when you're designing a game in your head or thinking about what you might like to make in your head. There's kind of a genre. Genre can mean something like a shoot 'em up, which is kind of the staple of video gaming, shooting pixels at other pixels. You move your little ship avatar thing around and you shoot at other things and you avoid their bullets and you avoid hazards. One of the earliest known video games was a shoot 'em up. This is called Space War. It was purely rendered by vector graphics, and it was very simple, but it was the start of everything. It was awesome. You can still actually play this in some places. Then you have the beat 'em up, which is kind of like the shoot 'em up, except up close and personal. They usually emphasize rock, paper, scissors style gameplay. Who's familiar with rock, paper, scissors? Excellent. The idea that everything that you can do has a counterattack or a counter, and that's very common in video games to have that sort of mechanism. And also, a lot of these games have memory game characteristics as well. So you have to memorize certain combinations of keys to press to do something special. So the little memory games as well. We have the platformer, again one of the staples of video gaming, which is basically those sort of action games while walking around and jumping on things and swinging and rolling and jetpacking and whatevering around. But it integrates a bunch of the same aspects of the shoot 'em up and the beat 'em up, sometimes. Puzzle games, which are more about contemplation and finding solutions to tricky problems, or just mindlessly clicking around until you explode. A lot of games that aren't Minesweeper or specifically puzzle games, a lot of other games also have puzzles built into them. Adventure games typically give the player a world to explore. You might also be given something to do in the game that can change the world in some way. Typically there's puzzles to solve. And then there's the action-adventure genre of games, which kind of blends the action and adventure genres together. So while you're wandering around the world, possibly changing it, you're also shooting things. Strategy games, which rely on the player's decision-making skills and thinking and planning. They're often about kind of an empire-level struggle against other empires, but they can also be quite abstract games, like chess or Go. They're usually slower, more contemplative, if they're turn-based games, or they can be full-on action, real-time strategy games, which kind of blend the action and the strategy. Some strategy games lean strongly towards being puzzles. So tower defense games are a good example of that. They're often more like puzzle games than strategy games. Then we have simulations. that focus on mechanisms that make the world tick. They give the player pretty direct control over the mechanisms that run the game. There's an emphasis on attempting to realistically model real situations. There's also vehicle simulations and aeroplane simulations, train simulators, which are also kind of action games as well. Then we have role-playing games. So in these sorts of games, the player's character in the game will grow or change or be customized over time in the game. The player can often change the world in some way. There's variations on the role-playing game, like Japanese role-playing games or JRPGs, which have a very specific formula, although a lot of those are actually more like simple action-adventure games. Even though the character changes through the game, it's usually on a fixed path. And then there's FPS, which some people call a genre, but I actually just think this is a different way of looking at things. The first FPS games were actually role-playing games, but with a very limited freedom to look around. They were often step by step through a dungeon. So there's roughly 6 different flavors that you can mix into a video game that I've mentioned as I've been going. There's the action, where the player's immediately doing something in the game. There's simulation of something that would be in the real world or possibly not. There's strategy, where the player has to think about what they're doing. And puzzles, where they're directly trying to solve some conundrum. Adventure, where the world is full of something or the world is full of things interesting to explore. And multiplayer, I think, is an aspect of genre as well, because when you make a game multiplayer, it will change a lot of the dynamics in the game, a lot of the mechanisms in the game. Then there's a bunch of little extras that you can throw in. These are like single little mechanics that you can add to one of those overarching genres, which can be combined in themselves. But these just kind of extend the game just a little bit. These were supposed to come one at a time, so this will be fun. So procedural content, where there are algorithms that define how the world is generated, rather than there being artwork and models and things that are being generated by artists directly. New Game Plus is a term that's used to describe when you finish a game, you can start the game again at an increased level of capability. So all of the experience and armor and whatever else you've collected through the first run through the game, you get to keep that and start the game again, and generally making it a lot easier. Final death, which basically means if you die at all during the game is over and you have to start again. That's quite popular with games like old school rogue-like games, text adventures on Unix computers. For some reason, very popular in those particular games. Nintendo Hard is a term that's used to describe games that were typically developed by Nintendo in the 80s and 90s, and some even more recent ones, which basically means some Nintendo games are actually really hard. Mario Brothers and some other games, like they look easy, but they actually get quite difficult quite quickly. Mini games, little games like you're playing along in an adventure game and suddenly there's a little video game console and you can play Space Invaders for a while. That's a mini game. It's just a little game that's thrown in that's quite different to the regular game, just for a bit of flavour. There's the rock, paper, scissors that I've already talked about. Auto-scrolling, where the game progresses regardless of what the player does. Quick time events, where you have to press a key at a certain time or you die, or you die. The introduction of physics into a game can be, again, that's something that can be added into any of the various broader genres. Stealth aspects make the game a big sandbox where the player can wander around and do a whole bunch of stuff and create things or just explore a vast world. the introduction of the player being able to program elements of the game, to compose simple programs in the game for things to happen. Altering the world. It's actually quite challenging from a video game design point of view, but players love it. Character growth, like in RPGs, is just an aspect of a bunch of different games. Real-time games versus turn-based games. Artificial intelligence. You can try and make things very, very smart in your game. Players tend to rebel against that sometimes because it's easy to make stuff that's much smarter than players. And turn-based games. So those are just a bunch of simple little mechanics, or single mechanics that you can throw in to mix up with any other sort of game. And that's not a comprehensive list. Well, it's quite a lot. Then there's some things to avoid, and again, I added these after I did the step-by-step things, so that's why they're coming up. These are things that annoy players. So if you have a game where there's limited save points, and so there's large amounts of the game that have to be replayed if they die or something bad happens, they have to load from a save that's a long time previous. Grinding, which refers to being required to go off and kill 20 orcs to get the new sword, to go off and kill 40 orcs to get the new axe, to go off and kill 20 dragons. That's grind. Killing 20 of something to achieve something is just grinding the player away at the game. Some people like that. World of Warcraft, I mean, it's huge. Instant surprise, giving the player absolutely no warning that something bad is about to happen to them in the game. That's a no-no. That's okay. I'm just still doing my introduction, so you haven't missed the meaty bits. Instant surprise death is here. Oops. I'll try not to do that again. Yeah, so there's instant surprise and then there's instant surprise death. Okay, so invisible or vanishing or moving platforms that the player has no hope of being able to deal with. Like they're just walking along and suddenly the platform disappears. That's not very nice to the player either. Give them some warning, or at least don't kill them if the platform disappears. Bosses that suddenly become invincible for a while, no matter how powerful the character is, especially role-playing games. They've gone battling through 120 hours or something of gameplay and they've become this invincible monster that can take on anything in the world, and then they get to the guy at the end and he's dressed in just a cloak and he's somehow invincible to all attacks until he's finished talking, and then you get to attack him. Stuff like that. It's just annoying. Ice levels. Ice levels where the only character that's affected by the ice in the level is the player. Everything else just walks around just fine. Yeah. Ice levels. Sorry, and goddamn bats. So these are famous. This is riff hard. There was a Nintendo game where there were bats that would attack the player from the top and the bottom, but the player could only shoot sideways. Don't have the goddamn bats. Hidden passages. Okay, so hidden passages can be good unless there's something really good behind them, in which case you're just annoying the player because they're like, how come that guy got that thing? And yeah. Artificial stupidity. This refers to AI that's gone wrong. Things like having to escort a non-player character in the game somewhere, and the pathfinding for the non-player character is so broken that it's frustrating, they die, and the player just gets frustrated and bored by the game that they should otherwise be fun.
You can't tell them to stay out of the way.
Yeah, yes, basically. All of that stuff. Artificial stupidity. No mercy and vulnerability. So there's a great mechanic which you can introduce into action games where after the player has died and they've respawned in the game, they're invulnerable for 5 seconds or something, gives them a chance to get out of the way of all of the bullets that are flying at them, whatever needs to happen, get out of the lava, something, so they can have a chance of continuing playing the game. Not giving the player that stuff, that's just dumb. All right, and zombie closets. I hate zombie closets. Zombie closets are basically used by game designers who just want to laugh at people playing their game. They're like, I can't believe you got zombie closet again. This is where you're walking down a hall and with no warning whatsoever, a zombie will pop out of the wall. And often behind the player, but sometimes in front. And it's just annoying as a player. Anyway, as I say, often it's the game designer just pointing and laughing. So that's genre and some mechanics of what you might have in your game. So that's kind of the first thing you'll want to think about is, it's basically defining the things that are going to happen in your game. Then we have the setting and the general flavour of the game and how it's going to look and feel. How the game is rendered is part of this, and this is where we come back to the first person thing. It's just a flavour, it's a setting. It's how the player interacts with the game. It's not part of the game mechanics usually. Although setting a game in first person versus a game in third person can change the game considerably. I mean, it's the same for literature. Reading a book written in the first person versus third person is quite different. But the rendering can be two-dimensional or three-dimensional, and if it's two-dimensional, then is it top-down or side-on? Is it 2.5, where you've got a fixed orthographic perspective, where you're looking kind of down at an angle at the gameplay? And beyond that is the art style that you're going to employ, the general overall art style you're going to aim for. So you're going to have aliens or zombies or pirates. I can't believe I left out ninjas. Is it going to be medieval or faux medieval? Is it going to be futuristic? Is it going to be in space? Is it going to be on islands in space? Is it going to be on land? Is it going to be flying in islands or something? Is it going to be is there going to be horror in it? Is there going to be romance? Is it going to be a western or space opera? Or are there going to be spies in it? Superheroes, steampunk. These are all things that are used in games all the time. Obviously you can, or not so much with the romance, but all the others anyway. And then again, this is far from exhaustive. And this is just a general theme sort of thing. So you want to think about what sort of game, I've left out farms and all sorts of other things. So there's things that you can think about. Important point though is when you're thinking about all of this and you're going to go approaching your first game, it's important that you keep your first few games small. The idea about them, the concepts behind them, the mechanics that you're going to try and implement, try to stick to one mechanic or two mechanics maybe and just focus on those. So if you're going to make a strategy game, just make it a strategy game. Don't go all fancy and add in a bunch of extras. Just focus on that one thing, just for your first few games. And also be prepared for it to just not work. I can probably show you some of my very first video games that I wrote back in 2004, 2005. And you will laugh, and I laugh at them because they are atrocious. But that's where I started, and I'm fairly happy that since then I've moved on and I've gotten better, and that's fine because that's how it works. You're not going to write Call of Duty the first time you sit down to write a video game. Start simple. Okay, so with that out of the way, let's build a simple video game. I'm just going to have a quick drink before I go on. Oh, I forgot to write down when the break is. It's 2:20, I think. Sorry? 2:50? All right. Cool. Okay, so to actually build a game, yep, thanks. To actually build a game, there's a few things we have to do. There's some basic elements that almost every video game has. We're displaying something on the screen. We're handling user input. We've got some mechanics, which I've just kind of talked about a bit. Those mechanics, we have to implement them somehow. We're going to play some sound effects and play some background music. And there's also an overarching sort of game architecture, which is very much like writing a regular bit of software. The software, the architecture, the structure of the code that you're writing. And I'm going to talk about that a little bit as we go today. I'll cover each of these kind of in turn. So, and an important point is that there are some games that skip some of these things, that don't display anything or that don't play any sound, and that's fine. You can do that if that suits the game that you're making. But I will be covering all of these today. So to display something on the screen, we have to open a window. Even if the game is a full screen game, you're still opening a window, it's just that it's a full screen window. Then we need to draw something into the window and probably move it around as well. So putting images up on the screen. So to display something on the screen, we can copy images onto the screen, an image that we've already constructed. We can draw pixels onto the screen individually using the PyGame draw module. We can put text up there with the PyGame font module. And we can skip all of that and use OpenGL, which is a modern system for rendering three-dimensional graphics, which I'm not going to be covering today. Oh, did I? Oh, okay. So that's the basic methods. So to put an image up, we can load something up off disk. PyGame can deal with PNGs and JPEGs. It can also deal with Windows bitmaps. If it's a PNG, and the PNG has transparency in it, then PyGame will handle that for you and blend that PNG into whatever else has been drawn onto the screen. You can also create an image using scientific or numeric modules, load them into an array in PyGame, and draw that array up on the screen. And you can also draw to a screen you can use all of these drawing mechanisms to draw to something that's not directly on the screen, and then you can take that thing and stamp it up on the screen in multiple places, or multiple times. So you can construct things off screen. So, to open a window in PyGame, if you'd like to, you can run the first example code, which is 01-open window. And if that does not work, you might want to find somebody near you who has it working. Now, if it does work, you will see a window just flash open very quickly. What's going on here is, very importantly, we import the PyGame module. PyGame does a sneaky trick where basically when you import PyGame, all of the other PyGame modules are imported as well. So you just have to import PyGame. If you want to access pygame.draw, you don't have to import pygame.draw, you just import PyGame. Pygame.init has to be the first thing that you run in your actual executable code in your program. Before you try to load any images off disk, before you try and display a window, anything like that, you have to invoke pygame.init. And then to create a window on the screen, we call PyGame display set mode. And it takes the resolution of the window that you want to see on screen, 640 pixels wide by 480 pixels high. If that's not the native resolution, if you're asking for a full screen window and that's not the native resolution of your display, then PyGame will scale your program to fit the full resolution of your display. It won't show a very small full screen window. So set mode takes a bunch of other optional arguments that I'm not going to talk about right now, one of which is asking for a full screen window. And that returns a screen, which is a surface that we can draw things onto, which we'll come to, obviously. But because this program doesn't do anything else, it just exits straight away. So the screen flashes up and disappears. So what we need to do is add something called a main loop to our program. All this is going to do is do exactly what we just did, open that screen, and then it's going to sit in a while loop, just ticking over constantly in the while loop, keeping that program alive. Inside the while loop, we look for a couple of things that might happen that we can say are our exit conditions for the program. So this is the simplest form of event handling that you'll have in PyGame, and it's also probably the most common. It's very, very simple and easy to use. So inside our event loop, which is the while running loop, we ask PyGame's event system to give us all of the events that have happened since it last got called. And that returns us a list of events which we can loop over in our for loop. Each of those events is an object which has a type. The simplest event is quit, and it only has a type attribute. And if we get the quit event, which is the event that the operating system sends us when the user clicks the close button on the window, or generates a quit event some other way, we'll just set our running flag to false. That's fine. If we get a key down event, which is basically the user pressing a key down on the keyboard, then we can look at the additional attribute on the event object for the key that was pressed. And if it's the escape key, then we can also quit. That's a really convenient thing to add to your games while you're programming them, because you're tapping away, you run your program, and it doesn't quite work, you hit escape. Really convenient, rather than going for the mouse to close the window. Just don't forget to disable it before you ship the game. So that's the quit event and the key down event. There's a bunch of other event types. There's the key up event, which is when the same key is released, you get a key up event. There's mouse movement events, mouse button press events, and other things. I've mentioned some of them on the quick cheat sheet that you've got there. And each one of those has a slightly different other set of attributes that will be set on the event object. So that's our program at the moment. And it's fine. A lot of your first games will probably just start like this, as just a bunch of code in a file like this with no real structure. But I'd like to encourage you to think about structure before you get too much further in your games. Think about the architecture of what your game is going to be. Because it's a simple thing to take this code and turn it into something that's a little bit more structured, that can make your code a little bit more reusable and re-enterable. So this it's basically the same code. It runs exactly the same as what we had just before. But instead of just having it all at the top level of our program, we have code that's standalone. It's re-enterable, which basically means we can create a game object and we can run that game object, and then it exits, and we can create another one straight away and run that second one. And an argument to the creation of the game object might be the level file to load for that game object. The class could be called level or world or whatever is convenient or appropriate for your game. And because we've taken the actual executing of the game and put it into our if name equals main block, it means that we can import this game from another module and run it from some other game file. The game is a really good place to store other things as well, like a player object and enemies list and a bullets list and whatever else. Things that various other bits of code in your game need to get access to conveniently without resorting to global variables. If you find that your game has got global variables in it, then you probably need to think about your architecture a bit more. All right, so that's enough about that. It's just something to think about. So drawing. Okay, so we want to draw something. In fact, this little character here, we want to draw this character up onto the screen. Once we've achieved the drawing of things up on the screen, we've pretty much got a whole swag of simple games that are available for you to write straight away. Adventure games, Tetris, Minesweeper, all those things. All you need to be able to do is draw something up on the screen. Before we can put this guy up on the screen, we need to have a quick discussion about how we tell PyGame to put him up on the screen in the right place. So the coordinate system is how we tell PyGame where to put the guy up on the screen. PyGame's coordinate system is old school. Y increments down the screen, which is completely the reverse of everything else on your computer. And it's done this way because of how screens were refreshed in the old days, which is serially, well actually they still are refreshed from this top down, but they're refreshed by reading video RAM from the start and drawing what's in the video RAM onto the screen and line by line going down the screen. And PyGame comes from the days when you used to draw directly into the video RAM, which was what was being drawn up onto the screen. We still use this top-down refresh mechanism today, even on modern LCD screens, but OpenGL and other modern graphic systems don't draw directly to the video RAM, and so they can use more sensible Y-up systems. But the Y-down thing, keep that in mind because it does get a little bit confusing sometimes if you forget about it. So, Y-down. So, to our little game class, we're going to add loading an image. Loading image is trivial. PyGame image load, you give it a file name. Again, JPEG, PNG. Because we're loading a PNG, the PNG has transparency in it. It'll be blended with whatever's on the screen already. To actually draw it up on the screen, inside our while loop, we're going to clear the screen first, clear whatever is up there currently, using a fill, and the fill is just filling the screen with a plain grey colour, which I'll get to in a moment. Then we're blitting the image up on the screen at a certain coordinate, 320 by 320 x 320, y 240, which is smack in the middle of the screen. And then we flip the display. I'm going to come back to each one of these in more detail in a moment. Oh, except I guess the blit. Blit, again, old school. It's actually an acronym. It stands for Block Image Transfer. It's basically copy. It says copy the image that it's being passed onto the screen. Okay, so colors. The color there is specified as 200, 200, 200, which is red, green, and blue. And the colors in PyGame are specified red, green, and blue. And the values range from 0, which is dark, to 255, which is full color. And you can get those color values from pretty much most drawing programs. Eventually, you'll just kind of remember a bunch of useful ones. The other part of that program, which is possibly a little bit weird, is the PyGame display flip. The reason why we have to flip the display is because we're getting around a problem with the refreshing of the video, what's being seen up on screen. There are two examples, bits of example code, which I'll warn you not to run if you have problems with flashy lights, okay? It probably won't work on a bunch of systems anyway, but just in case you do have an issue with flashing lights, do not run 04-tearing. But if you don't have a problem with that, then you can give it a try. Hopefully you'll see a bunch of flashing red and blue. Anyone? Yeah, it didn't work on my Air, but it did work on my previous laptop. Anyone? No? Oh. It's kind of hard to force it to do these days. Or certainly from PyGame, it's hard to do. Hey, there we go. Oh, and can you see that kind of transition line going up and down the screen, or up the screen? Did you want to wave it around? Okay, and anybody want to look away? I don't know. Okay, so what's going on there? It's the same sort of thing that's happening in this display here, where this is an example of an actual video game, or demo game, where the screen is tearing in very much the same way, where there's these discontinuities in what's being drawn up on the screen. And the reason this happens is that the game code is writing new image to the video RAM while the display system is sending the video RAM to the monitor to display it. So it gets halfway through sending the image to the screen when the image is changed and suddenly it's drawing a new image to the screen. So in that example, I'm drawing red and then I'm clearing to blue and then clearing to red and flipping very quickly. And so you're actually seeing that cut between when the video refresh is happening. It's also why, so one of the way that we fix this, hang on, I'm skipping ahead there. Okay, so yes, that's drawing directly to the screen. Even modern screens suffer from all of this. So the solution is to draw, instead of drawing directly to the screen, we draw to something that's not on the screen. And once we've finished drawing, once the screen is finished refreshing, we switch what's being displayed on the screen to the stuff we've just drawn. We do this flip. And we do that, again, once the display system has finished drawing everything up onto the screen and it's going back to the start. And that process of going back up to the start of the screen to start drawing the screen again is called the vertical sync. And that's why you see the term VSync in video games, to prevent this tearing problem. It's also called double buffering, where you've got a buffer on screen that's being displayed and a buffer off screen that you're drawing to, and you flip the buffers. If you don't remember to flip the buffer, you won't see what you're drawing. Okie dokie. Another problem with our program is it's using a lot of CPU because it's just looping constantly, very, very quickly, drawing as quickly as it can. So what we're going to do is introduce something that'll slow the program down so that we're only drawing 30 times every second. Because we're going to be developing an action game, I want to have a reasonably fast refresh speed. So 30 times per second is pretty good for an action game. If this wasn't an action game, if it was a puzzle game where there's nothing else going on except the user clicking on things, then there's another mechanism we can use. But you can ask me about that. I'll talk about that later maybe. But what we're going to do here is we're just using the PyGame clock facility to slow us down so that the clock.tick will sleep a little bit so that we're not being called more than 30 times per second. If we're being called less than that, so if your computer is slow, it's not going to speed it up somehow. It's just going to stop it from going over that 30 frames per second. Okay, so now that we're drawing something up on the screen, let's move it around. To move it around, it's pretty simple. Instead of blitting or copying that image that we're drawing to the screen into a fixed position on the screen, we copy it to somewhere that's defined by a couple of variables. We have an X and a Y variable that define the position that we're going to copy that thing onto the screen. And inside the loop, we just have a fixed point where we increment the X position. And so if you run 0.6 animation, then you'll see the little stick figure wander off the screen. And if you'd like to open that, once you've run that, if you'd like to open the file in an editor, in a text editor, try moving this screen.fill to just up above the while loop, where the while loop starts. Outside the while loop. Make a pretty pattern? Yeah. So that just means we're not clearing the screen each time. So the PyGame actually retains what was previously drawn on the screen in the new draw buffer. All right. So that's drawing stuff up and basic animation. And obviously you could write this so that the little character doesn't just go all the way off the screen. It could go to one side of the screen and then come back again with some simple if statements, a couple of other variables, whatever, move it around in circles. Fairly straightforward to do those other things. What we're going to do now, though, is introduce some user input, because I like video games with user controls. So I've already talked a little bit about how we get events from PyGame. PyGame provides us with a couple of different ways of getting information about keys that have been pressed on the keyboard. We can get the events that come out of the PyGame event.get, which gives us the key up and key down events, which is saying the key has been pressed down or has been released. In a game like the one we're creating though, the player is going to be holding a key down for a long time to move around. So we would have to then remember, oh yeah, we saw a down event and we're just waiting for the up event, but while we've seen the down event, we should move things around or do whatever. That can be tricky to manage, and fortunately PyGame has a very simple facility for managing it for us. So it'll actually remember all of the keys that have currently been pressed down, and we can ask, which keys are currently being pressed down, which makes that sort of code, the sort of code we're going to be writing, much easier. But it does mean that there is a small chance that if there is a key that's going to be pressed very quickly, like the escape key to quit the game or a space bar to shoot a bullet or something like that, then we might miss that event of the key being pressed down if it happens outside of the time that we're looking at that key state thing. There's a very, very small chance that that could happen. So that's just something to think about between the two different mechanisms. So what we're going to do is we're going to replace the fixed increment of moving the little character around the screen with looking at this table of keys that are being held down that PyGame manages for us. And we can, it just looks like a dictionary, and it has a Boolean value for every key on the keyboard. So we can just say the left arrow, right arrow, up and down arrows, are they currently being held down? And if they are, then we can modify the X or Y position so that we move the character around. And that is in 07 user input. If you'd like to run that, you can give it a little try. And the arrow keys should move the little stick figure around. And because we don't want to miss that escape key being pressed, possibly very, very quickly, we keep that in the old PyGame event get loop, which can still run while we're still using this other mechanism. That's fine. We can have both running at the same time. But it just does mean we don't miss any very, very quick impulse events from the escape key. So some other user input events that we can see out of PyGame event get are things like the mouse button being pressed and released and movement of the mouse. That's not even English. Okay. Okay, so again, very much like the keyboard, the mouse button's state can be a bit tricky to manage if you want to remember when it's being held down. So you can actually query PyGame to find out which mouse buttons are currently being held down. PyGame doesn't make mouse buttons very fancy. They're just numbers 1, 2, 3, 4, 5, which, believe it or not, that's left mouse button is 1, middle mouse button is 2, or the scroll wheel being pressed is 2, right mouse button is 3, scroll wheel up is 4, and scroll wheel down is 5. If you actually look at the operating system level, the scroll wheel comes in, certainly on Macs, the scroll wheel comes in as like a floating point change value. But PyGame just simplifies that down to it was scrolled some amount. Anyway, it's good enough for most games. So that's mouse events. Okay, so while that code achieves our goal of moving a character around the screen under the control of the user, it's going to make writing something more complete and more complex a bit of a challenge if we have that state in a couple of variables and we use it in a loop like that. And what we're going to do is organize our player character into a sprite. And a sprite is a term that's used in video game programming as to encompass the idea of an image that knows about where it's being drawn on screen. And PyGame actually extends that idea to include the actual bounding area that the sprite has in the game. So the player sprite has the image that we were drawing before, but it also has this rectangle which says where that image should be drawn on the screen and how big it is. We can then use that later on just to detect whether or not it has collided with something. And also note that the player-specific event handling, so all the things about moving the player around, I've moved that into the actual player sprite class itself as well to kind of keep things a bit more organized there. So that's the player sprite, and again, extending the base PyGame sprite. We do need to do a couple of other things to make this work. We obviously have to get rid of the loading the image over there. But we need to, the way that PyGame organizes sprites is all sprites have to belong to a sprite group. Even if this group only has one sprite in it, you have to have the sprite in a group. The group then manages the drawing of the sprites and the updating of the sprites. And I'll come back to the updating stuff in a bit. So we add the player sprite to a simple group just called sprites. And then instead of drawing, or instead of blitting that image up on screen, we invoke the draw method on the sprite group. We pass it to the screen, and the group figures out which sprites need to be drawn and draws their image up on the screen. There's a bunch of other different sprite groups that can be used. I've just used a very basic one here, but there are some other ones which are optimized to figure out specifically what things have changed on screen to minimize the amount of drawing that's done. But I'll leave that as an exercise for the reader. Okay, and you'll notice if you run that code, which is 07, I think, 08, there's no change in the game or the program. It still works exactly the same. It's just we've reorganized things to keep things a little bit more sane. The main event loop is now smaller and more organized. If we can keep things out of the main event loop, that's a good thing. Okay, another thing that I mentioned before was that when we call clock.tick, it'll limit the amount of number of times it'll be called per second to 30 times per second. But if it's being called less frequently than that, then it can't do anything about it. So that means that if your game is running on a computer that's running slower than 30 times per second, so 20 times per second, then your game will slow down. We can cope with that, and it might just slow down sometimes, or it might just be running slowly. We can cope with that because the clock tick actually tells us how much time has passed since we last called it. It returns the amount of time in milliseconds, which is a bit inconvenient, but it does tell us how much time has passed. So we can then, when we then update our player movement around, instead of updating by a fixed amount, we can update by amount per second. So we can say the player moves at 10 pixels per second rather than just 10 pixels, which means that if the player's computer is running slower, they'll still move at the same speed across the screen. And because it's more sensible to work with values in seconds, I always just divide whatever's returned by clock.tick, I divide that by 1,000 to get a seconds value rather than a milliseconds value. Yeah? It can. The height and width can be different, but the top left corner of the rectangle defines where the top left corner of the image is going to be drawn. So you can kind of have the other sides not be the same, but you have to have that top left corner be the top left corner of where the image is going to be drawn. If that makes sense. Okay, so another thing to note here is that where we were previously just calling sprites.update, which is the method on the group, we're now passing in an argument, which is the amount of time that's passed. Sprite groups deal with that by just saying, oh, you passed me an argument, you must have wanted to pass that on to all the sprites. So I'll just pass that in as argument to all the sprite updates. So it's quite convenient like that. So when we go and look at the player code, we just add the DT, the change in time value, the time that's passed value, we just add that as an argument to the sprite update, and the group will just pass that in. So then, instead of, as I say, instead of moving by a fixed 10 pixels per update, we're moving at 300 pixels per second, which is actually the same speed. It's just that if your computer was slower, it'll be slightly faster. But for pretty much everyone in this room, it'll mean that the character is moving at exactly the same speed. But we're being a bit more controlled about it, and that's a good thing. Okay, more fun stuff. Right, so we've got a character up on screen, but there's not much else there. So all we need to talk about is how to construct the rest of what's going to be displayed on the screen. It was 250 was the break, wasn't it? 250. Yeah. So we construct our what's being displayed up on screen in layers, which basically means we draw something at the back of the screen, usually by clearing it or drawing a background image, and then we just draw something on top of it. And we draw some more stuff on top of that. And we do that in a kind of a layered way, a layered scheme, drawing them from the back to the front. So at the back, we draw sky, usually, and a nice fixed blue. We can then draw some background imagery that appears behind the player. If the background imagery moves at a different speed to what the player is moving in the foreground, it'll look like it's way off in the distance. So you can draw that, you can move that around at a slightly different speed. That's called parallax. We can also have, so the purple mountains could be drawn at a different speed to the green hills. So they could move faster with the player, and they would appear to be closer. We can then draw things that are in the foreground, which include the player, that should appear moving at the same speed as the player, but just behind the player. We would then draw the player character on top of that. And then we can draw other things that appear in front of the player, and obviously a bad example because I don't actually have anything appearing in front of the player, but things that would appear in front of the player like grass and other things just down on the ground. It's nice to have those sorts of things obscuring the character sometimes. Our little game is going to be very simple. We're just going to draw a background image, and it's just a straight color fill. Actually, no, it's a gradient. So that's in 10, the example 10-background. And it's very simple. Instead of filling the background with a straight grey color, we load a background image and we copy that up onto the screen each time. I was going to say something else then. Yeah, so you can make that background image pretty, you can clouds in it or whatever. Yeah. Okay. So, now it's time to add something more interesting for the player to do in the game. So this is where we start talking about our game mechanics, like the game mechanics I talked about much earlier. So the player controls are obviously part of the game mechanics, how the game responds to the player hitting the keys on the keyboard. We can also have things appearing and disappearing or moving around according to how time passes. The player can interact with other things in the game. In a platform game, they interact with the platforms by stopping moving, or if they're spikes, by dying. We can detect important events in the game, like the player reaching the exit and winning the game, or hitting the spikes and dying, and doing that enough times that they lose the game. So we're going to start off with the middle. Well, we've done the player controls a little bit, mostly. We're going to start off with the middle one, though, the interaction of game objects. So we're going to put something into the game that will prevent the player from moving around. So, to do this, we have to talk about collision detection. there's 4 basic collision detection methods that are used in most 2D games, and in fact, most 3D games use extrapolated versions of these 4 basic mechanisms as well. The first method, and by far the most common because it's the easiest, is the axis-aligned bounding box test. Axis-aligned basically means that the bounding box we're defining around the player and other things in the game that the player is going to interact with, the sides of those boxes are aligned with the x-axis and the y-axis. Much easier to work with than something that is tilted and not aligned with the axes of the game. And this is real easy because it uses the dimensions of the original images. So we can do a very simple test to see whether or not those 2 rectangles or those 2 boxes overlap. And if they do, we have a collision. Unfortunately, there's a fairly large chance, certainly in these 2 images, that we'll get false positives. So the images clearly don't overlap, but the bounding boxes do. So a variation on this is to reduce the size of that bounding box so that it's slightly smaller. Yeah?
So I guess I have 2 questions. If the player image is multiple images, so you can do motion like have the wings go back when you're moving, right?
Oh, okay. So if we decompose the player ship image into like one rectangle there and another smaller one there and another smaller one there.
Yeah. How would you do that in the player class, and also how would you account for that?
You would have to code something very specific. Well, you could have 3 sprites, would be the simplest approach. But otherwise, you could have something specific in the player class to, you would have a custom collision test in the player class to test against those 3 rectangles. Yeah. Reducing the size of the bounding box, if you can do it, will reduce this chance of false positives. And actually, it'll probably be a little bit more fun for the player anyway, because it gives them a bit of leeway. The game isn't quite so strict on them. And that can be good for fun. The next most common test is comparing circle to circle. And again, we just define a circle by saying the center of the image of the sprite and the radius, or the so the radius is just defined by the width of one of the dimensions of the sprite. Hopefully they're square sprites. And that fixes one of our false positive cases reasonably well. They're in exactly the same position as they were before, but we're not detecting a collision, which is good for the player. Unfortunately, so there's a collision, but unfortunately there's a collision that's missed now, which again kind of gives the player a bit of benefit, which is a bit more fun anyway. So isn't necessarily a bad thing. Most asteroids type games use circle-to-circle collision for basically this reason. And for something like this, the player probably wouldn't even notice in a fast-moving action game anyway. They was like, ooh, that was a close call. The third type of collision detection uses hash maps, where we take the playing area and we divide it up into buckets about 10 pixels by 10 pixels, or maybe even 16, or maybe 8, depending on what works for your game. And then for each of those buckets, we go through all of the images in the game and we figure out which buckets the image is in, even in just a small part. We can then quickly test, say for the player, we can say, right, well the player's in these 9 buckets, we can quickly test whether there's anything else in any of those 9 buckets. And we can say, right, well there's something in there. We might just use that as our test to say, right, well there was a bullet in one of those buckets, the player's dead. Or we can then go on and use another more precise collision detection method to see whether the player is hit by the bullet. This is really easy in Python, obviously, because we have these wonderful hash maps built into the language. It's really easy to do. The final collision detection mechanism is pixel perfect collision detection. And it's the mechanism that a lot of people, when they're starting out writing video games, say, yeah, this is the one I'm going to use. And it's overkill for pretty much most games. There's, I think, 3 games that I've played ever where it actually needed to have pixel perfect collision detection. And that's because you were actually shooting things into the ground and the ground was exploding, like the actual bitmap of the ground was exploding. 2D games, they were great fun. And then you were jumping around on the actual pixels of the landscape. So you needed pixel perfect collisions there. Shoot 'em ups and other sorts of games, you're doing way too much processing, doing pixel to pixel comparisons for collision detection. So just don't bother unless you really, really need it. Yeah. Well, precisely. That's sort of, if you were simulating pixels of sand colliding with each other, yeah, you need to be able to do that sort of test. You would tend to have the information about those sand particles, you would have them in some other sort of array system, which is able to process that array information very quickly, rather than accessing the pixels of any surface data, so the actual imagery. Because accessing PyGame and display pixels, pixel by pixel, is very slow compared to accessing a numeric array, for example. Or a NumPy array. Sorry, I'm showing my age there. Okay, so that's those mechanisms of collision detection. All right, so let's do one. First up, we're going to add some obstacles. We're going to do it in the most simple way possible. We're going to have a couple of loops and we're going to add walls around the play area just by looping and putting an image, which is a sprite, which is a picture of a block. And we're going to whack that up as a border around the play area. Now, you'll notice that we've created a separate sprite group for this called walls. And we're actually storing the sprite group away on the game. This is inside the game class. We're storing that sprite group away on the game object as the walls attribute so that we can get at it later on. When we update our sprite groups now, we're going to pass in the game object to the update. So now we're passing the time that's passed and the game object itself. So that when we're in our player update, we get the time that's passed and the game object, and we can access all the stuff about the game from that handle that we've been passed in. We take a copy of our position. The PyGame rect objects have this handy copy method. So we take a copy of our position, and then after we've done all our movement updates, we see whether or not we've collided with any of the walls, and if we have, we reset our position to the last position we were at. The Sprite module has this wonderful Sprite collide thing that quite quickly goes through, given a sprite and another sprite group, it'll go through all those sprites in that sprite group, so all of our wall blocks, and see whether we collide with any of those, just by doing a simple overlap test. We pass in false, because by default, anything you collide with will be removed from the group, which we don't want. We don't want the wall bits to actually be removed from the game. So the false argument, if it was true, the wall bits would actually be removed from the wall if we collided with them. So you can try running that. That's in 11. And give it a go. I want you to try running up to the wall. Try running along the wall. Yeah?
Yeah, you can. What happens if you wanted to actually check what direction you're colliding with the wall from?
We'll come to that.
Okay.
We'll come to that. So everyone tried that? So you've noticed anything odd about that? You're not supposed to be. You're not supposed to be able to do that. Although, actually, it's in theory possible. But anything else?
I hit the wall one time going right, then I went left and came back and didn't actually hit the wall.
Oh, okay. There might be a bit of a boundary issue there. Yep. It's a very cheap and nasty way I'm doing it here. Yeah? Yeah. That's right, yeah. You'll stop some distance away from the wall. Yeah. Is there anything else that anybody noticed? So if you try moving right up to the wall and try sliding along the wall,
Like hold up against the wall and then try to move.
you can't move along the wall. Yeah. Okay,
Like
some people can. Yeah, hold both directions.
Or try holding left and right.
Left and up and left and down or
Left and
something.
right and up and down at the same time are also.
Well, that will stop you dead, yes.
No, it doesn't.
Oh, doesn't?
You actually slide slightly left or slightly up.
Awesome. Oh, floating point rounding probably, yeah. Yep, excellent.
Random question, you don't really answer this. I noticed when I was moving around, it felt like I was moving faster horizontally.
Oh yes, you are, because the way that the movement is calculated, if you press the key, you get or if you press one direction, you get 10 pixels per second that direction. If you press another, you get 10 pixels per second that direction. The vector addition of that means you're moving at whatever the vector addition of that is, 15 pixels per second that way, diagonally? Yeah.
I'm talking about if I go left to right, it seems like I move faster than if I go
Okay, that could
It
just
might have
be
something to do with pixel size.
something like that, yeah. Pixel aspect maybe. But yes, you will move faster diagonally. You can address that in a game quite easily by using some trigonometry, which I'm not going to go into. Trigonometry is not scary. Repeat that to yourselves because you're going to be writing games. Missing that it's been held down. Yeah, it's not being held down. So that's what I was talking about, that if the impulse event, yeah, where the key has been pressed so quickly that it's happened before your game code is run again.
Can that accuracy be increased by messing with the clock?
Oh yeah, you could update the clock faster, but if you desperately need those impulse events, then don't use the get pressed. You should listen for the key up and down events yourself. Yeah. Okay. So yeah, there's heaps of problems with that code. It's all over the place, but it's a start. It tells the basic idea of how we can have the player interact with stuff in the world. It's a start. So to address the first of one of those things, which is, well, second or third, I've forgotten how many bugs you brought up, but the thing where we're not going right up to the wall, what we're going to do is change the collision detection so we have conforming collisions. Conforming just means we bring things together. So this does mean that we need to keep track of which side we're colliding with. So things get a little bit more complicated. So instead of just saying reset us back to the last position where we're at, we have to figure out which side of the player collided with the block in the world, and then align the player side with the side of that block. Fortunately, PyGame's rect objects give us these handy left, right, up, down, or top, bottom attributes, which give us the actual sides, the position of the sides of the rects. So we can just say if the player is collided with the right-hand wall, we can align the left side or the right-hand side of the player with the left-hand side of the wall block, and that'll line them up nicely. If you run 12-conforming, you'll see that in action. Assuming you don't just go straight through the wall, as some of you seem to be doing. You still can't slide along the walls though. Unless some of you can. Most of you won't be able to slide along the walls. Okay? But we'll come back to that, because let's add a bit more fun. Gravity. All games are improved with gravity, or physics in general. To introduce gravity to the... Oh.
I am
Yeah. There'll be a small margin of error there, yeah. Right, so we need a couple of bits of information to keep track of gravity. The first thing is how fast the player is moving in the y direction, and we store that in a variable called dy, which stands for delta y, or the change in y. It's just shorthand rather than y_speed or something like that. We also have a flag called resting, which will be important. That indicates whether or not the player is resting on a surface. You might be able to guess why we need that, but don't spoil the surprise. So we're going to skip out the up and down controls. We don't want those anymore. And we're going to replace them with a test for the space bar. If the player is pressing the space bar and the character is resting on a surface, then the character can jump. And we jump by introducing an impulse or setting the y speed to -500. Remember, y increases down in PyGame, so -500 is up at 500 pixels per second. No. What? That's 60? No, not 60. 12 pixels per second. 12? Oh. Anyway, that's some number per second. Yeah, it's not 12. 17. The other thing we do is then, so after we've introduced that impulse of setting the jump speed going up, you can try this out. Oh, no, don't try it out yet. Well, you can, but we've got a couple of other things to talk about. So we can go up, but we obviously have to come down again as well. So we're going to arbitrarily set gravity at 40. It seemed to work for this game. Excuse me. That was weird. Oh, I forgot to turn my Wi-Fi off. Okay, so the magic number 40 that I've got in there, which is basically, that's the amount we add on to our y speed each update. I should really be mixing that in with the amount of time that's passed as well, but I think I just forgot. I arrived at that number by just playing around and seeing what value worked, what felt right for the game. And you'll do the same thing. Gravity changes depending on what works for the game. We also cap the vertical speed at 400. If we go too fast, we might go too fast to detect collisions with the floor. We'll go straight through. So always remember to cap your speeds. And then we just we increment or decrement our y position accordingly based on the y speed. So we need to set this resting flag. So in our collision detection code in our player class, we'll reset the resting flag, and then if we happen to be colliding with a floor, then we set the resting flag to true. And if we are actually standing on floor, then we will collide with it every turn because gravity will pull us into it every update. It's also handy for if we have disappearing floor. So if the floor just goes away in one update, then we will fall through it and we're not resting anymore and it's all good. If we are resting, or if we in fact collide upwards, then we set the y speed to 0, just to clear things out so it doesn't get too out of control. Especially the colliding upwards. We want to hit things going up. Oh, actually, and I can demonstrate a reason why you clear the y speed if you're standing on something. We can show you why that's important in a moment. If you'd like to run 13-gravity, if you haven't already, then you can run around and press the spacebar and jump around and stuff, and it's awesome. Almost awesome. Yes, you can jump up onto the wall. And you can then jump back out and jump up further, yeah. Although it's quite tricky sometimes to get that second jump. The wall is sticky. But don't worry, we're going to fix that in a moment, in fact. But remind me, once we've got platforms, oh, I've given that away. that we should talk about this dy resetting thing because it's kind of funny. Okay, so that's all cool, except it sucks in a few different ways. So let's create a proper map to play in, a proper map that's got proper collision stuff in it. Because that's kind of taught us the basics, but we're now going to extend it a little bit more. So what we're going to do is introduce an actual map into the game that's been created with a common tool, and it's in a common format called TMX. And we're going to use a library to manage our interaction with the TMX format because we're not crazy. Well, I'm crazy because I wrote the library, but you're not crazy. Well, you might be crazy. I don't know. We're all crazy. There's a bunch of TMX libraries, and I didn't like any of them, so I wrote my own. And there's a bunch of TMX tools, and actually they're mostly all cool. But we'll come back to the TMX tools. Okay, so tile maps. So we've just created our playing area by taking a block and whacking it up on the screen in a regular pattern around the screen in an ordered grid. And that's basically what a tile map is. It's an ordered grid on the screen where, at the moment, it's blank. The tile maps have got cells in them. They're actually square. Don't believe the rectangular looking tile map there, but it's actually square. This map is made up of 32 cells by 32 cells, and the cells can be empty. Most of them are. Or they can have contents. So here we've got two tiles that we're drawing onto our map. We've got a square tile that's being drawn into a bunch of different places, and we've got a triangle tile that's being drawn into a few places there. Two tiles being copied up into multiple places on the screen. And you can make an interesting map just with those tiles. Well, semi-interesting map with just those two tiles. Those two tiles, the square and the triangle, form our tile set, the set of tiles that we're going to use to draw up into our tile map. So we have a tile set, which is a bunch of different images, and they are drawn up into some array of tile cells based on what the cell says its tile is. Okay, again, the TMX library kind of handles most of this for you, but you need to know this basics. We use this awesome editor called Tiled to create our tile maps, and I'll be coming back to a demo of it, but in short, it looks like this. It's a little bit blurry. Oh. Anyway, it looks like this. You've got a tile map in there where we've got that block image that I was using before, arranged in, there's like a border, and there's some platforms there. We've got a tile set which only has one tile in it, unfortunately, but we'll come back to that. And it's got layers and a bunch of other stuff. When the tile map is drawn on screen, it looks like this. So the map is made up of cells, and the cells have tiles in them. This is the entire map, drawn scaled down, which is 50 by 50. I think. Yeah, again, it should be square. I don't know what's going on there. The player only sees a limited view of that map, usually. The TMX library handles that, but that green section there, that's called the viewport. That's the player's view into the game world, the viewport that they're looking through. Okay, and that'll move around the game along with the player, and the TMX library, again, handles that. We tell the TMX library where the viewport is by telling it where to focus the viewport. So if we tell the TMX library to focus down here, it'll place the viewport as close to that position as it can. If the player moves up here, the viewport will follow that focus point. If they move over here, then the viewport will be off in this corner. It won't move outside the map and display things that are outside the map. It'll handle all that for you. Because that's kind of semi-tricky to do, but it handles it for us. The tile map has layers. So it has those grey blocks, but it also has another layer on top of it, which defines some triggers in the game world. Triggers are the things that the player interacts with. The player doesn't interact with the images that we've drawn in our tile map. The player interacts with the triggers that we define in the trigger layer. So here we've got two triggers. We've got the red boxes. Those are things that the player can't go through. The player will bump into those things. So we're in our program with the for loop, we created a whole bunch of blocks. Here we have one single rectangle which the player will collide with, and that solves that problem that we had of the player colliding with blocks as they were trying to slide along. The other trigger that we have is the player start position. So it's not something the player interacts with while they're playing, it just tells the game where the player should start playing. That's where the player will spawn when they come alive. The P is marked with a special flag that says, I'm the player start. The other rectangles are marked with a special flag that say, I'm a blocker. And these are done in TMX by editing properties that say whether it's a player or a blocker. So that's the P-tile properties. We'll come back to all of this stuff. To use the TMX library, you import TMX. So as I said, there's like a bunch of TMX libraries out there. None of them called their library TMX. Anyway, so I got the name TMX. Weird. You import TMX. To load the tile map, we have to get rid of all this stuff that we did before with generating walls. And we replace that with TMX load. TMX load needs the name of the map tile map file. Unfortunately, when I was writing this, I got a bit lazy and I called the map. There's a couple of other TMX files in the directory there. Oh, by the way, they're ASCII files. You can look at them. They won't hurt your computer. Anyway, you give it the file name. You also tell it how big the screen is so that TMX knows how big the viewport is. Oh, I just realized it's 2:50. It's break time. Do you mind if we pause there? I can kind of start this a little bit again. But how about we pause there and go and have a break? Yeah, 20 minutes. So I'll see you back here at 3:10. Okay, so tile mapping. Yeah, we've got a few people who haven't made it back in, but that's okay. Okay, so where were we? Okay, so we're replacing all this with loading up a tile map by supplying the file name of the tile map and the dimensions of the screen, which tell the TMX library how big our viewport should be. Obviously, you could have passed it a different size if you wanted to render to part of the screen. Now, because of the way TMX manages the scrolling around the play area, we now need to use a sprite layer that's managed by that library rather than just a regular PyGame sprite layer. Otherwise, it won't be scrolled around with the rest of the game. So our old sprites layer group, right, our old sprites group is now replaced by a sprite layer that's managed by TMX. The other thing we need to do is figure out where the player starts. Now, again, the tile map provides us with a simple, a nice mechanism for accessing that information. When we load up the tile map, as I said before, it's got two layers. There's a layer which is drawn, that's got the cells or the tiles that we're drawing, and then it's got the layer that's got the trigger information. And one's called map, and the other one's called triggers. So we access the triggers layer. It's just a dictionary of layers. And we ask it to find all the cells that have the player property set on them. There's only one, but we find all of them, and we grab the first one, and we start the player at the position of that cell. The start cell's X and Y pixel coordinates. And the player sprite is the same as before. We haven't changed the player sprite. It's the same sprite. We're passing its start position and the sprite group that it belongs to. We also add the sprite group, the sprite layer, to the tile map so that it's also rendered. So it just becomes another one of the layers that the tile map is going to be drawing. The background is static, so it doesn't change. It stays where it is, which is now, yeah, so we still just blit the background screen up on the screen as it is because it doesn't move around. And so now we call the tile map update and we pass it the same arguments as before. It behaves just like the old sprite group. And we call draw on the tile map, just like we did with the Sprite group. So all that API is basically the same. It's just that we're using the TMX variants on the regular PyGame Sprite groups. Yeah?
Can you explain on the previous slide what you were passing in the player?
What am I passing in the player? Okay, so when we were constructing the player previously... Okay, so the previous player construction just hard-coded where the player started, as in it was just hard-coded in the init of the player sprite. Now we actually have to pass in the position that we want the player to start at, which is defined by looking at in the tile map. So the two arguments are the x and y coordinates of the player start position, and then there's the sprites group, which is the group that the player sprite belongs to. Oh yeah, sorry. Yeah, no, I used px and py because the TMX library has a concept of x and y, which isn't the same. So that's all good? Yep. Okay, so yep, covered that. So yes, the player sprite, I lied before. I said it doesn't change. It actually does change. We add the location that the player starts at as an argument. So then instead of hard coding where the player starts, we start based on where the tile map says we start. Oh yeah, and another bit. So yeah, I lied about this too. We can't use the PyGame Sprite collide mechanism. There's an eccentricity in the way that the PyGame Sprite collide is implemented that it's hard to extend. So I just said I'm not going to try, and I just made a slightly different API. So we ask the layer, the triggers layer, to give us back all of the things in that layer that the player is colliding with. We can also say only collide with the things that have the property blockers set on them. So we won't get back collisions with the player start position or any other triggers that we have in the triggers layer, and there'll be a bunch more. We won't collide with any of those unless they've got the blockers property set on them. So that limits the number of things we have to test our collisions against. The rest of the collision code is exactly the same. The thing coming back looks exactly like the sprites that we were colliding with before. The last thing we have to do is right at the end, after we've updated the player's position, is tell the tile map to set the focus on the player's position so that the viewport will move around as the player moves around. So that was a bunch of changes, but it's not overwhelming, I hope. We've just kind of switched from using basic PyGame groups to using this tile map groups and moving the view around a little bit. If you run 14-tilemap, which I certainly didn't change significantly only 2 hours ago, it should work fine. And you should be able to walk around a much larger map than we had before. And there'll be platforms that you can jump on. Now once you've done that, assuming that that worked, nobody's yelling, so I assume it's working. Once I've done that, so something to experiment with is to open up that 14-tilemap, and in the player code, actually might just do this here. Hang on, let me actually do this. So in the player code, where are we? So where we've zeroed out the dy when we land on a platform, if we remove that, we don't want to not zero it out when we hit the bottom of a platform, but when we zero it out, we remove the bit where we zero it out when we hit the top of a platform, when we're landing on a platform. If we remove that and run it, now if I jump up on there, right, now if I fall off of here, It's kind of hard to see, actually. My y speed is retained when I fall off here and then fall off the next platform. It's kind of hard to see, actually. If I don't zero out the y speed, then it's retained, and when I fall off the next platform, then I fall very quickly rather than falling gently to start off with. Anyway, didn't really work as well as I thought it might, but oh well. Okay, play. So the platforms. One of the things you might have noticed when you were playing that, it wasn't quite as much fun as it could be, because the floating platforms in space, you couldn't really jump up on them except if you were on the side and you jumped over onto them, which isn't as much fun as just jumping straight up onto them. So what we can do is we can mark those particular things as being a special kind of blocker. They only block movement from one side, which is the top. We can mark all the other sides as being passable by the player, so the player can be underneath the platform and jump up on top. So that means we need to change our concept of the blockers property that we set in the TMX file, so that instead of it just saying I block, it says I block these particular sides. So our TMX file now has this. It has a nice feature where you can actually give the shapes that you're adding into the file, you can give them a name, and that name is then displayed next to the shape, which is really nice. So, and lots of things can have the same name. So I've given platforms the name platform, and then I've given the blockers the name TLRB, of course. So for the TLRB blockers, I set the actual value of the blockers property to TLRB. And for the platform, I set the blockers value to just T, which stands for top. Everything else blocks from the top, left, right, and bottom, and the platform blocks from the top. And then in our collision detection code, we can test for those letters being in the blockers property. So if, the important one being this one, if T is in the blockers property, then we test to see whether or not we're hitting that side. Otherwise, we ignore it. So all of the other ones, L, R, and B, for the platforms, we don't even do those tests. And so the player can now jump up onto the platforms. And you can see that if you run 15, which I think you will agree is a little bit more fun. It also means we can have things like ladders in our game. So without this change, if we had a ladder, then the player wouldn't be able to climb up through a platform, possibly down. Okay. So this is good. We're forming the basics of a platform game here. We've got the basic platforming going, which is good. We've got jumping and we've got platforms. Now we need enemies. So, to have enemies, I've got an old screenshot. Sod. To have the enemies, we need to know where they are in the level. We need to know how they move around and whether or not they do anything else, like shoot at the player. Do they alter the level in some way? So do they open doors or set things on fire or something else? Do they have special moves? Do they jump around sometimes or jump on walls? These are all things that you might implement in enemies. I apologise for the old screenshot. The red blocky bits, just imagine they're like the previous red blocky bits, not like these red blocky bits. The important elements of this screenshot are this trigger and this trigger, the two different trigger types. With those two triggers, we've got enough information in the map to have a basic enemy in the game. One trigger says, says to the game, create an enemy in every place on the map where I have an E trigger. So this will cause 4 enemies to be created in the game. The other trigger says when an enemy collides with one of these reverser blocks, tell it to turn around. So the enemies will just move mindlessly in one direction until they hit a reverser, and then they'll come back again until they hit another reverser. Make sure you have one on both ends. The enemies don't even need to implement gravity because they never fall. They just move from reverser to reverser. Very, very simple stuff. A little note on the idea of triggers here for enemies. Side-scrolling shoot-'em-ups use basically the same sort of mechanism for enemies. Here we have a really simple representation of a playing field in a side-scrolling shooter. The red box is the viewport, the triangle-y thing's the player, and the black, that's the entire playing area. In this sort of game, the viewport moves at a fixed speed, usually, across the playing area. Sometimes it might stop for a while, but mostly it just moves across. So, as the viewport moves across, it can sometimes come upon triggers in the map. And so we can have an event that basically says when the trigger is exposed onto the viewport for the first time, we create an enemy at that point or off the screen at that point. And that's how most side-scrolling shooters work. They just have a bunch of trigger points. As they are activated, when the viewport hits them, we create an enemy. And there's pew-pew. You can do other things with these triggers as well. You can trigger music, sound effects, special effects, all sorts of things, not just create enemies. It's basic synchronizer stuff. That's how music synchronizers work. Anyway, you can do all sorts of fun stuff with that. Has anybody played Little Big Planet? Yeah, okay, so there were people who wrote music in Little Big Planet using triggers just like this, in the first one, not even the second one. Okay, so our enemies are pretty simple. This looks a little bit overwhelming. It's a bunch of code, but it's actually pretty straightforward. A bunch of it's very much like the player. We have an image. Note that we've got the image for the enemy as a class attribute rather than an attribute, as an instance attribute. That's fine. It just has to be an attribute property of the object eventually for it to be useful. We also need to know which direction the enemy is moving. They move at a fixed speed, so we don't care about the dy or dx actual value. We just need to know which direction they're moving. 1 means right, -1 means left. In the update, again, very simple. They just move at a constant speed. They don't collide with anything except the reversers, and if they do, then we reverse the direction. We make sure that we align the side of the enemy with the reverser that they've collided with. Otherwise, the next time we come around, they might re-collide with the same reverser, and they'll just wobble. We also checked for a collision with the player. For each of these enemies, we check to see whether we collide with the player, and if we do, then the player's dead. The player only gets 1 life in this version of the game. And to manage the enemies, we have a separate sprite layer in which we create an enemy for each of those E blocks, which I've marked as with the enemy property. We create 1 for every one of those in the playing area, and we add that to the tile map. Everyone okay with that? It's just another layer. It's got some more sprites in it. The player obviously needs to know when he's dead. And if the player does die, in the main loop, we return from the main loop after printing you died. Obviously, you might want to put something more complex here, like, sorry. If you'd like to play 16 enemies, then you can try that out. You'll have little enemies going backwards and forwards. And if you collide with one, it'll just say you died. Okay, so that's all cool. Then we've got some bad guys. We really probably should give the player some sort of defense against this, right? Apart from jumping. The player can quite happily jump across them, but shooting them would be more fun. So the first thing we need to do with the player to shoot is we need to know which direction the player is facing. And to give the player some help with this, we should show the player which way they're facing as well, rather than just being this stick figure. Okay, so we're going to have two images now. We're going to have a player facing right, player facing left image. And we're going to keep track of the direction that the player is moving as well, like we did with the enemies. So if the player hits the left key, then we display the player facing left image. If we hit the right key, we display the other one. And we, again, keep track of the direction so that when we're moving, we know which way we're facing. So we remember which way we're facing. Know that to change what's being displayed for a sprite, all we have to do is change the image attribute. And then the next time the player is drawn, we see a new image. Obviously, if you wanted to animate the player in any way, like for walking or jumping or whatever, you just have to change the image attribute. It's pretty simple. On that note, so we've got very basic image animation that we can do there. We just have to change that image. We can change the position of the image, and we can change the picture of the image over time. We could also introduce running and jumping animations if we had time. There's plenty of really good source material out there on the internet. This is these are various movements from a classic book called How to Animate by a guy, Preston Blair. It's basically been the go-to book for training animators for decades. There's samples like this and countless other ones like it out there on the interwebs that you can use as source material for figuring out how to do your character animation. This is a pretty crappy animation that I did a couple of years ago, before I found those reference pictures. But still they worked. The game that they were in kind of worked. The character inspired by Kiki of Kiki's Flying Delivery Service, and the actual walking animation was basically I did a very, very, very simple motion capture of my daughter. But it kind of worked. One tip though, when you're making your animations, keep all the frames the same size, at least when you're starting out. Don't have different size pictures for each frame. Otherwise, you're going to be causing trouble for yourself. You can get into different size framed animation later on, but when you're starting out, just go with a straight 16 by 32 for a character like this. And so make sure you keep track of, use your DT value, the amount of time passing, for your frame animation rather than just counting the number of frames that are passed, just to keep things consistent. Special effects like explosions, that's just a series of images that are displayed over time. So, yeah, an explosion would be just to display, starting off with the first one, just cycle through them quite quickly when something happens. Okay, so that's basic animation stuff. So, shooting. To allow the player to shoot back at the enemies, we need to keep track of a few things. Where the bullet started its life, how long it's going to live for, because we don't want bullets to last forever if they don't hit an enemy, or we're going to be keeping track of a lot of bullets. We also need to limit the number of times the player can shoot per second. Otherwise, they will just spam the bullets, and that can be not a good thing. So, we're going to create a new class called Bullet, which is going to manage each one of the bullets that the player shoots. There are other ways, if you're going to have lots and lots and lots and lots of bullets in your game, you might not want to create an object for each one, but for this game, this is a much nicer way of keeping track of things. Yeah? In the bullet? Oh yeah. Yeah, it's not being added to a group there. Let's just see what happens in a little bit. All right, I'll keep going with the exam. We'll see. Okay, so again, the image is just a class attribute. That's fine because it's the same image for all of the sprites. all of the bullet sprites. We know that we need to know the direction that the bullet is traveling in, even simpler than the enemy because it just keeps traveling until it dies. We've got the rect and the direction and the lifespan of 1 second. The first thing we do is we decrement the lifespan based on how much time has passed, and if it goes below 0, we kill the sprite. Self.kill on a sprite removes the sprite from its group and garbage collects it and removes it from display, and it's gone. We move at a constant speed in the direction that we were spawned in, and we try and collide with the player. And if we collide with the player, then if we collide with the enemy, then we remove the enemy that we collided with by passing true to sprite collide. Remember, if we pass true to sprite collide, it automatically removes the sprite that's collided with from the game. And then we also kill the bullet so that it doesn't just continue on and kill everything else. We need to limit the number of times the player can shoot per turn. So we keep track of how long it's been since they last shot by keeping a gun cooldown attribute. And then if the left shift key for shooting is pressed and we're not cooling the gun down, then we create a new bullet in the direction that the player is facing, give it a lifespan, give the gun a cooldown of 1 second so they can only shoot once per second, and then we decrement the gun cooldown, stopping it when it hits 0. Yeah, so that's passing game.sprites, but the constructor obviously isn't taking it. But so the example 18, that doesn't work? Oh, okay. If you try 18, then I imagine it'll work, because I'm pretty sure I tried them all before I started. Sorry about that. Yes, you just need to, you've probably fixed it anyway. Yeah. Okay. So that's cool. We can shoot back. We can kill all the enemies. Woo! Now we need sound effects. Oh yeah. Sound in PyGame is as easy as the image stuff. You load a sound file and there's a single call to play the sound file. I can hear you all. And playing background music is just as easy. It's like you just say, please play this MP3 file now. And eventually you can say, please stop playing the MP3 file. So you can play 19 sounds and you'll get sound effects. An important point though is, so when you're playing the sound effect, you just call .play on the sound. If you're going to be doing that a lot, you might want to put some limit in your game code to limit the number of times you call that in some time period, because you can overload the mixer on some computers if you try and play too many sound effects at once. It'll just start sounding really crappy. So we load up 3 sound effects by just referencing the wave files by file name. And that's just on the game object. Again, handy place to store these files, these objects. And then at various important parts of the game, like when we shoot or when we jump or when we die, when we shoot an enemy, we play the appropriate sound effect. Again, we can access the game because we're passing that into the update method of all these sprites. We can do all sorts of things by accessing the information on the game object. So instead of having the sound effects as global variables, we can keep them on the game object and then they go away when we don't need that game object anymore. We might move on to another level which has different sound effects. We're not keeping those other sound effects around unnecessarily. Those sound effects were all generated by this cool tool called, this is CFXer, but the original tool is called SFXer. It's actually SFXR. So CFXer is the Mac port of the tool, and I'll come back to it. It's really trivial to make 8-bit style sound effects. So that's most of our game, most of our simple game. We've got some things that we could add to the game at this point to make it a more complete game. We could have a number of lives and a display on the screen of how many lives the player has got left. We can detect that game over event and just display a nice message, or we can detect when the player has won. I'm not sure what the winning of the game is at this point, but you could just have an exit door that you need to reach or something like that. You could have a nice opening screen with some, like about this game and some options if there are any, like turning off the annoying sound effects. And all these other things that you can add to a game to make it more complete. So that brings us to scenes, or adding a start menu. And we're going to use another third-party bit of software called Kes menu to construct an opening menu for the game. There's the code. I'm not going to go into it in great detail. It's basically the Kes menu API. This is a separate file to the game file that we've been editing so far. This is the standalone thing. You can see at the top there, from platformer, import game. So that's what I was talking about right at the start, about our game being nice and discrete and standalone, re-enterable, all those nice things. We can import it from our other code to say, yeah, I'd like one of those game objects now. And then when the player selects the play option from the menu, we launch the game main loop right there. And that goes off and runs the game. Kes menu stops here because it's the same program. It just launches off into the game. When the game is finished, it returns from its main loop. We come back to Kes menu, and Kes menu says, oh, okay, I pick up there. I'll go back into my main loop. Oh, menu update is where it does the launching off into the appropriate options. And that's how you do scene management in PyGame. You have one event loop, and at some point you might decide that you need to display a game level or an options menu or something else. And so you launch off into its main loop, and it runs until it's finished and does its own drawing, and then you come back to where you came from. And that's how you manage scenes in PyGame. And you can see that by running 20-scenes, if you haven't already, which I imagine most of you have. Okay, there's other things you can add on to games to make them more fun. There's the simple image animations that I talked about already, the explosions and walking animations, things like that. There's more flashy stuff you can add, like particles. Every single game is improved with the use of particles. And by particles, I mean every time you shoot the enemy, it explodes in a shower of somethings. There's libraries in Python called like Lepton, which nicely encompass all you need to do with managing particle engines in Python. It's actually got a C backend. It's really fast. It's almost no overhead in your game, and it can manage thousands of particles. This all falls under the kind of the heading of juice. There's a great presentation online, which I've lost the reference to, unfortunately, about adding juice to your game. And they basically start with a basic breakout game, and they add more and more extraneous stuff. It seems like extraneous, like particles and flashy graphics and sound effects and things. But the game just becomes so much more fun with the addition of each one of these like dozen or so elements that they add, which are basically particles or shaking the screen or things like that. The nice thing about Lepton is that it works with PyGame and OpenGL, so you can use it in both, in a bunch of different projects. Okay, so that's kind of where I'm going to leave off with the game that we've been developing today. Actually, did that game finish with the different tile set? I can't remember. It's 20? Yeah, it has a different tile set? Yeah. So we'll get to that. Some other game types that are included in that source that you've got, that I implemented, these all took me half an hour tops each to write. Not even that in some cases. Yeah, Minesweeper, driving a car around. Side-scrolling shooter, as I said, was really easy to write. It's just a TMX map with some different triggers, and the playing area scrolls across. Tower defense game. It's got a pathfinding algorithm that the creeps in the game have to follow, but that's a fairly simple pathfinding algorithm that's in the source. So you're welcome to poke around at those games and do what you will with them, just as the rest of the stuff. So Minesweeper is a really simple game. You render some cells, you detect mouse clicks, you see what's underneath there, and you change the image. It's pretty basic stuff, which is obviously why it was included in Microsoft Windows. So car driving, it's again a tile map, just a slightly different player control system. Trigonometry in there, I'm going to warn you, but it's pretty straightforward. The thing that's not done in that demo file, though, is detecting when the player has gone off the track. Exercise for the reader and all that. But the basics of the control system are there. The side scroller, again, I've been over that. And tower defense, yeah, the movement solution, or figuring out what path the creeps should take, depending on where the towers have been placed. That's the complex bit of that game, but again, not too hard. On to packaging. Once you've finished your game, or once you've got a game that's almost finished and you want somebody else to try it out, you generally want to package it up into something that they can run on their computer without installing Python and PyGame. So we do have the tools that we can use to generate Windows executables and OS X applications, Linux, Android applications. Windows executables, there's a thing called Py2exe out there. If you have a Windows, you need to have a Windows computer to do this. You have to install the 32-bit version of Python. You need to install PyGame into that. Then you need to install Py2exe. And then you need to make a lot of guesses. Py2exe has been around for a long time and it's still not documented. It's insane. There's a wiki, and there's in amongst the front page of the wiki is a link that's just called General Tricks and Tips. And that's where the bulk of the documentation is. And even that is very thin. I eventually got it going. I'm not entirely sure how. This is the this is part of the Py2exe file. It took a long time to get to this point. If you do need to do Py2exe, I recommend Googling a lot, because there's a lot of people out there who have done it before, and there's a lot of information out there in Google. Yeah, so you can get there in the end. It's got a bunch of, where are we? Oh, this does some slightly strange stuff with the target thing, because this is for the game called Match 3 that's in the subdirectory of the files that you got there. The actual script for that is called main.py, because Android. So I have to rename it for Py2exe, so that otherwise the exe that's generated would be called main.exe. But yeah.
Do you have any recommendations for throwing it up on the web or recommendations against?
Throwing it up on the web. As in playable in a browser? You can't. Yeah. Rewrite it in something that runs on the web. Yeah, no. I'll tell you now, there is a Python to JavaScript converter, but just don't. That's only part of the file. The rest of the file is that, because I need to also include all my data files. And I need to do it very manually. Find all the data files, and then add them to a directory, which is then included in the exe stuff that's generated. And Py2exe actually generates a directory which has got the exe file in it and a bunch of DLLs and some data files and some other stuff. You then have to zip that up, and that's what you give out to people. And they unzip it, and that's the game. Okay, the OS X application is a thing called Py2app. Py2exe, Py2app. Doesn't work. I did this Py2Applet thing and it broke all over the place. And it's undocumented as well. So then I found PyInstaller. PyInstaller is actually pretty good. It's kind of weird that you download PyInstaller, you unpack it, and you do all your work in that unpacked directory, which is a bit weird. You don't install anything. But it generates, so you run in PyInstaller and it generates some stuff, including this a directory with this spec file in it, and then you edit the spec file according to the rather thin documentation to then feed back into PyInstaller to generate your app. PyInstaller can also generate exes. I haven't tried it. I imagine it'll probably work a lot simpler and a lot better than Py2Exe, but I haven't tried it. This is certainly a more recent project than either of the other two, so I can only hope that that means that it's more stable. The spec file is mercifully short. It's got a bunch of these PYZ and exe and collect and bundle things are really obscure. They're not very well documented. To get all of my game's data files into the bundle that's being generated, I have to add a TOC, which is then added as data files in the collect thing. So data files is a TOC. TOC has things in it, it's kind of a list, and it has tuples in it, but nowhere in the documentation does it say what the tuples have in them. Eventually I found in the source that they have these two file names and a data in quotes. I don't know what other options there are other than data. Anyway, I eventually got it going. It's a much shorter amount of code to generate the thing than Py2Exe and Py2App, so that's a good thing. And it worked. It generated an app that I could actually give to other people and they could run. So that, as far as I'm concerned, is a win. No X11. Well, was that a historical thing that they needed? X11? Wait, you didn't install the Linux version, did you? No, it doesn't require X11. That's weird. Okay, I'm curious now. All right, so that's Windows and OS X. I think actually PyInstaller I think can generate stuff kind of like applications that you can install for Linux as well. But I certainly didn't try that out because I do not have access to an appropriate Linux system. Android, as it turns out, was a breeze compared to all of this, especially the PyGame subset for Android. I took my little match 3 PyGame game that I'd written with no modifications. I ran this android.py build game thing, release, install with my phone plugged in, and within a couple of minutes I had of like woe to go, I had my game running on my phone. It was insane. So that's awesome. The only downside with the PyGame subset for Android is that PyGame on Android runs entirely in the CPU, which means that it's a little bit, it's actually quite well optimized, but it's a little bit inefficient compared to using the more graphics-y oriented hardware that's in most of the phones. But also it means that you get no bells and whistles. You can't do any sort of alpha channel transparency, fun, fading things in and out. There's certainly no transforms into like three-dimensional or two-dimensional rotation transforms, things like that. It's beyond what PyGame already provides, but again, CPU heavy. So I thought that was pretty cool. So I then said, well, that's neat, but I'd like to make the game a little bit more flashy, add a bit of juice. So I tried out the Kivy project, which I'd previously used for a couple of other games, and tried out its Python for Android offering, which, again, really straightforward, except Python build.py flags. Yeah, let me see. That's the flags. So the command line experience isn't as nice, but it works. And it builds an Android application, and away you go. I did have to rewrite the game. Kivy is not PyGame. It doesn't operate in the same way that PyGame operates, but it didn't take me very long. Again, I'd written stuff in Kivy previously, but it didn't take me a very long time to rewrite Match-Free, which is really a very simple game, in Kivy. And I built and released and installed on my phone, and I had the game on my phone, and then I added some more juice, and I've been doing that for a little while now. That's the PyGame subset for Android creates a little information file about your game. You just have to edit that to change the version information and maybe change the name and a couple of other things, and then it refers back to this when you do subsequent builds to release. Both of them get a bit fun when you actually go to release stuff in the Android store, because by default they have their own release key built into their build systems, and you have to change that if you're going to release stuff under your own name. But it's just a bit of fiddling, but it is possible. All right. So that's deployment. Oh, and the Android store is $20 to register forever. So this is why I didn't have any qualms putting up a free game. I haven't put it up in the Apple Store for that reason. It's not going to be it's going to be free. I can't see charging money for it, but I can't pay $100 a year just to have a free game up in the Apple Store. So let's talk about the content tools that I've been referring to. And we'll jump out of the slides over to here. Right, let's look at SFXer first. Or this is, as I said, this is the Carbon or Cocoa version called CFXer. Let's see if I can. Right, so the interface is for if you just want some sound effects quickly and straight, then the interface is pretty simple. There's different classes of sound effects. So coin pickups, shooting, where are we? And you can just get random sound effects, which is what I was doing before. If you want to, you can muck around with the specifics of a waveform to try out different things. I'll give it a try, but I don't actually know how the middle stuff works. But you can just drag the sliders and hit play. And what do we got? I don't know. Repeat speed, what's that do? And away you go. You can if I change it to a sawtooth instead. So you can do all this stuff, and each time you make a change, it generates a new sound effect file over here. And you can go back to one and hit export, and it generates a wave file, and you can PyGame sound or PyGame mixer load whatever it is that wave file and play it in your game, and it's that easy. So yeah, at least when you're starting out. Just generating your own sound effects, trivial. And certainly easier than trawling around all of the free sound effect websites to try and find something that's not going to violate copyright horribly and be suitable for your game. Yeah? There's a Flash version, which you can run in your web browser. There's a bunch of versions, yeah. What this program is doing is actually emulating the SID chip from a Commodore 64, the sound interface device chip from a Commodore 64, emulating it and generating sound effects in the same way that it generated sound effects. So it's pretty neat. Okay, so that's SFXer, the go-to thing if you just want sound effects really quickly. I can make that go away too. Okay, so the next thing I'm going to show is this awesome tool called Pixel Edit. Now, Pixel Edit is an Adobe Air program, but it's awesome. And I've lost my mouse. Where is it? There we are. I'm so glad this screen's down here. This is brilliant, whoever thought of this. All right, so there's Pixel Edit, beta. Oh, that's a bit dark. Sorry. Can we get these lights turned off, please? Cool, that's good enough for me. Okay, so Pixel Edit is a tile set generating program. Okay, so the thing about when you're creating tile sets, the thing about tile sets is you want your tiles, whatever, you want your tiles to be seamless when they're butting up against each other. So you have your ground tile, and then it goes into wall tiles, and might go into overhang tiles, and all the different tiles. You might have several different ground tiles, and you want them to blend into each other. Then this program is awesome because it makes it easy to edit those tiles. So what we've got is a tile set over here. It starts off with 8. It starts off with 8 tiles to start off with. Oh, I can look down here. That's right. Starts off with 8 tiles in the tile set. Adds them automatically as you need them. And oh, that's terrible. Let's see if I can. That's better. Mousing on a black surface. Right, let me just remember. Oh, now I need to change something for this to be useful. By default, the tile sets are 16 by 16. Cancel, wrong one. Tile. Resize tiles. Yeah. Yeah, the tiles are 16 by 16 by default. For our purposes today, 32 by 32 is more convenient, so I'm going to do that. I'm going to scroll out, hit space to pan around. The user interface is a bit programmery, but it's not too horrendous. Space to grab things to pan around and stuff. Okay, so to edit a tile, we've got our tile set. I select the tile that I want to edit, and then I click in my edit area where I want to edit that tile. So I'm going to say that tile 0 is going to be my sky tile. So I'm going to edit that in these 4 boxes. And then this one's going to be my ground tile, and it'll be under the sky tile. So now, if I take my fill tool, select my sky color, if I fill this square here, it sets the tile to that color, and all of the other places where that tile has been used get updated. I can put in a little puffy cloud. Little puffy cloud. What's this? I hope this is white. Little puffy cloud. Terrible programmer art. All right. Okay, so there's my little puffy cloud, and you can see the tile is updated in all the places it appears as I draw. That in itself is really, really awesome for when you're generating tiles, because you want to see how they appear when they're repeated multiple times. Gets better than that. Okay, so that's that. So now I've got my ground tile here, and my ground is going to be brown. Where are we? Brown ground. I'm going to have, let's see, I'm going to have a wall-ish tile here, and that's going to be brown as well, because ground is brown. And a facing wall over here is going to be, that's going to be there as well. All right, so that's cool. The wall tiles, should have a bit of sky on them on one side, because that's, they face up against the sky. So I'll just cut away a little bit there, the wall, make it look a little bit cliffy. Okay. Bear with me mousing to edit something that's way down there. And that's the other side, so cut that out a little bit. Now obviously you can tweak this stuff to make it look nicer as you go, but this is just rough. There's some good videos of people using this tool as well to show you how to use it. Let's see, the top of the ground should be green. Now if you hold down Shift, obviously, when you're drawing with the pen, it draws a line. So I draw a line across the top of the tile there. and the top of that one there as well. Okay, and that's my grass. Okay, and what I can do is, where's the, no, wait. Okay, in the tool thing now, which one is it to draw? Okay, so if I select my sky tile and I hit shift and click it, it generates a new tile taking a copy of that tile contents. And the reason I did that is because I would like to have a sky tile that has grass at the bottom. And so that's a new tile. It's not affecting the other sky tiles, but it's a tile that has the sky background with some grass. Really poorly drawn grass, but grass nonetheless. All right. What? Oh, it's a blue flower. Honest, it's a blue flower. I got the wrong. I selected the wrong blue. Okay, I'm going to get rid of the clouds because they're annoying. Where are we? So I'll fill that in, and this one didn't change because it's a copy. And the copying process is really nice because it does also mean that I can say, take my ground, shift to stamp out a new ground there, and then take my pencil here and I can go dot, 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 to put in some, texture in the ground. And then I have two different ground tiles that I can use to break things up a little bit in the game. And I can see what they look like in a row by saying, well, okay, there's a bunch of those, and there's the other ground tile. So I'll alternate between the two, and that looks kind of okay. It's not too obviously tiles. Well, it is, but I'm not very good at this. All right, so that's my tile set. And you can add more and more tiles, and you can generate, overhangs and whatever else you need to do, doors and stuff. And it's really quick and easy to generate this stuff. I'm far from an expert user. Now, if I save that, save as test, because that's a good name to save it as. That's my tile set. Now, I'm going to fire up tiled to generate a tile map. Ooh, tiled doesn't like this screen. Let me see if I, ooh, sorry. See if I can make that smaller. All right, there we go. So now, the first thing I need to do is load up my tiles that I've just created. So I need to create a tile map. My tiles are going to be 32 by 32. Okay, it's showing me the grid there. I can zoom out. There's my tile map grid. I can add a new tile set in the map menu that you guys can't see. Oh, hang on. Wait a second. Let me do this sensibly. Okay, the map menu, I say new tile set. I'm going to call it the test tile set, and the image will come from the test tiles.png. The tile width and height 32 by 32. That's the wrong thing. Oh, oops, sorry. Pixel edit, export tile set, save. Okay, so new tile set. There we go, there's my tile set. Okay, so I have one layer, which I always call map, which is the basic tile map that I'm going to be drawing. And then I can draw my tiles. Where's my fill tool? There's my sky. So I'll fill the map with the sky fill, and I can take my ground tile and draw it along the bottom. I can take my alternate ground tile and draw it in every now and then. I've got my side tile, which I'll whack over there. Oh, I forgot to make a corner tile. That was a bit silly. So if I go back to pixel edit, oh yeah, I need a corner tile. So let's have that one's corner, that one's corner there. Fill, oh, where's my fill? Fill. And because it's a corner, we'll just have a nice little nick of green there and there. And we'll just say that's good enough. Save and export. Replace. So now I've got these two new tiles. It automatically detected the tile set had changed. So now I have these two new tiles. One there, one there. And I put some grass on top. With that blue flower that looks not at all repetitive. And that's, that's basic tile mapping. Now, I then can go in and say, right, well, now I need an object layer. And I'll call that triggers, just like in the code we've just created. And in the triggers layer, we use rectangles. Now, I've just got to make sure that my grid is being snapped to when I'm drawing these rectangles. Otherwise, they're not aligned to the tiles that I've made. So I now can define the blockers in the game. If I edit the objects there, I say blocker and blockers value TLRB. I can then take that, copy it, and save that as test, because I like the name test. Now, if I take my, oh I know what I've forgotten. I forgot the other trigger. Player. So now if I edit the platformer code, to load test, and then cross my fingers that I haven't forgotten anything, because I'm running off of a very vague shush. Hey, look at that. It's the map that I just made. Although, interestingly enough, look at that, the triggers are being drawn. And that's because they're visible in the editor. If I make them not visible in the editor, resave it, come back here, they're gone. And that is how easy it is. But that took me like 5 minutes, 10 minutes. Pretty cool, huh? And, try to count, just quickly try and count how many platforming games you've played. There's a lot. And it's such a nice format of video game. So, platforming game. And this is why we have 48-hour game programming challenges. Because it's so quick and easy to throw together some games. Yes, you're only just starting out, and yes, it's not going to be as quick for you to start off with, but you get a couple in, and it's, easy. It's good fun. All right, so where to from here? We jump back to, oops, turn off mirroring, play. Okay, so that's content creation tools. That's writing a game and creating the content for it. Oh, so the 48-hour challenge, Ludum Dare 48-hour game programming challenge, it's run quite frequently, 3 or 4 times a year. They even have 24-hour challenges if you can't quite find 48 hours. They have a rule that you must enter alone and you must create all of your game art assets. Everything for the game has to be created, all of the code, during the 48 hours. You can use libraries like PyGame, but you can't use a library that implements gameplay. So anything that actually implements a game mechanic, you can't use that. You have to write the game mechanics from scratch. So you couldn't, for example, you couldn't take Minecraft and write a mod for Minecraft to implement some gameplay and say, there's my entry, because the game has already been written. You're just writing an extension to it. Okay, that's LD48. In recent years, they've added an extra, slightly easier entry category where you can do it not solo and using... Oh, no, I still think you need to create all the assets during the 48 hours. I think they might also have a slightly longer challenge as well, but I'm not sure about that. I think they just relaxed the solo thing. It's because of LD48 that I started writing video games again. It was the LD48 challenge in 2004 that I entered, and I wrote a terrible game involving ducks. I have to see if it works. Yeah, there it is. All right. You'll be disappointed if this doesn't work, I'm telling you now. Oh, yeah. Ducks. 48 hours. Yeah, baby. All right. So, it's a very, very complex game, really. Your favorite pot plant is missing. Save it from the ducks. All right. So, the ducks... Sure. Wait, the duck's coming up on me there. Okay, so you're walking around. Terrible, atrocious movement. Oh, I found something inside this building. Woo! It's a skateboard. So now I move faster. Oh, a bullet. That'll come in handy when I encounter the ducks. Let's encounter a duck. I didn't quite get to sound effects. Where's this damn pot plant? It's got to be around here somewhere. Out of the way, duck. I have a life, and I have lives, and I have bullets, and I found a snack. That's good. Okay, I found something. It's a snack bar. I already have a snack bar. I don't need another. Oh, it's terrible. Come on, where's my damn pot plant? Not my pot plant, my potted plant. Just make that distinction. Yeah, I wouldn't let ducks get out. No. All right, really? It had to be in the last building I looked in? There's my goddamn pot plant. Okay, so you get the pot plant, and it goes on to the next level. Sorry. Level 1 completed, on to level 2. Your goldfish is missing. Really? And there's more ducks, and it gets harder. And eventually you die. It actually does get challenging. And it originally was a zombie game. There is actually a board game called Zombies, I think. And it's in this format. I basically ripped off this board game format and made it an action game where you're trying to escape a city, and it looks kind of like this, except less crappy. And the zombies are chasing you. The ducks are like, yeah, whatever. Just don't mess with me. Don't get in my face. I biff harder now. Excellent. So that was my first ever game as an adult. And I'm actually kind of proud of it because, I did it in the 48 hours and it worked mostly. It's still crappy, but I'm really glad that I did it because I then went on and did a bunch of other games. And you will too. So let me jump back to, unless I closed it. My most recent game, actually, I write most of my games. Okay, so the point was, LD48, I thought it was so awesome, and unfortunately, the guy who started it, Jeff Howland, he had other things that he had to do, and so the next time around, he couldn't run it. So I ran it, and then I ran another one. I actually hosted it on my own website. But by the time I'd done 3, I'd actually thought, you know what, I had a new daughter, and you couldn't dedicate 48 hours of a weekend with a baby in the house to writing a video game. And I wanted to play with my friends. So I created a new challenge called Pi Week, which basically is write a game over a week, you can play with your friends or you can go solo. You get rated, there's a winner in both solo and team entries. And you can play with your friends. You can use existing artwork as long as you have license to use it. And it's just a bunch of fun. The only stipulation is it has to be a Python game, because I like Python. So it's the Python Game Programming Challenge, and I've been running that for like 8 years now. And it's a bunch of fun. So most of the games that I write are done during the week. So having said that, let's see. The most recent game I've written is Match 3, which is the Android game. But I've got a bunch of experimental games on here. I've just got to find the actual PyWeek games. Let's see. Okay, so here's, I think, the most recent. Oh, here's. Okay, I'll come back to that one. AGA, there it is. All right. So this is Abby's Grand Adventure, which is a game that I wrote for my daughter. Actually, I don't think I'm going to be able to run this one because let's just see. All right, I'm just installing something because fortunately I have a cache of it, so it's just got to compile it. Won't take very long. Yeah, it leapt on because I didn't have it installed. This is a newish laptop. So yeah, that's not good. Okay, sorry, can't show you that. Oh, hang on. What am I saying? Take one of the copies that worked. So this is about 12 games later. All right. What on earth does that mean? OS 10 and it's broken ass bloody Python. No, sorry. I'm being foiled, so I can't show you that one. Wait a second. Yeah, no, sorry. This laptop's too new. I haven't wrangled it to that point yet. Sorry, bear with me. Yeah, that's not. All right. Yeah, no, there's a bunch of stuff missing on this laptop, unfortunately, and it would take me too long to get it into the state. So the more recent games that I've written don't just rely on PyGame, they rely on other funky stuff like Siphon and other things like that. So, sorry.
Do you have any advice or anecdotes for getting into games more publicized rather than just pleading to it?
No. No, because it's never been something I've really engaged in. Sorry. Even my little Match 3 game, like it's had a couple of hundred downloads from the Android store because I just don't publicize it. I don't want to. It's just basically friends and friends recommending it to friends. Darn. Just trying to see. Yeah. Yeah, sorry, back to the presentation. I can try and find some other stuff that might work later, but for now, I'm wasting time. What happened to the presentation? What happened to the presentation? Oh, there it is. Okay. Because it's 4:23. So, PyGame.org, obviously, where you go for all things PyGame. If you still think you need to learn some more about this, I've bamboozled you entirely, then there's a book called Invent with Python, Invent Your Own Games with Python. It's a really nice book. It goes pretty much from scratch through to writing a game, just like I have. Different style, and it's a book, so you can refer to it. So that's nice as well. There's a free download, or you can get it printed. And then there's pyweek.org. The next PyWeek is in just over a month. It runs for a week. It's international. It goes from midnight UTC one Saturday to midnight UTC the following Saturday. And yeah, a week is more than enough time to throw together a simple game. And it's good fun. And you should do it. That's all I have in terms of presentation material for today, and I'm happy for you to ask questions, but before you get too distracted and go, I'd like to ask you to help out with the conference. The conference